pictures of that packet.
Oh, yeah.
Thank you.
All right, the first thing that you are always going to do is pick a equation and pick a variable, okay? So that's the first step. Okay, so you're going to pick an equation and pick a variable. Okay, there's variables that are easier to pick than others. Okay, you want to isolate a variable, so you want to look for one that has a coefficient of 1 so that you're limiting the amount of work that you're having to do. Okay, so for example, 1, what do you think a good variable would be to isolate? X, right? Out of which equation? The first one, okay? So always start with numbering your equations in different colors. Okay, so we're going to take that first equation and we are going to isolate x. Okay, so my first equation is x minus 6y minus 2z equals negative 8. And I need to isolate x, so I'm going to move everything to the other side. So x equals a positive 6y plus 2z minus 8. Are we good so far? Okay. Now I'm taking equation 2 and 3, and I'm substituting x in for those equations. Okay, so equation 2, I have negative x plus 5y plus 3z equals 2. Okay, I'm substituting in my x here. Okay, so now I have negative, open my parentheses, 6y plus 2z minus 8 plus 5y plus 3z equals 2. Okay, you want to make sure that you never forget to open up these parentheses. It's not just negative 6y, it's a negative and then the entire x term. Okay, so make sure you open those parentheses and distribute that negative all the way across. Okay, so now when I distribute my negative, I have negative 6y minus 2z plus 8 plus 5y plus 3z equals 2. Okay, combine your like terms. Okay, I have a negative 6y and a positive 5y, so that's going to be negative y. I have a negative 2z and a positive 3z, so that's going to be plus z. Okay, and then I want to move my constant to the other side, so I'm going to subtract 8 from both sides. Okay, so I have negative y plus z equals negative 6. Are we following along so far? Okay, now that you have that, name that equation number 4. Okay, so name that equation number 4. Okay, now we need to focus on equation number 3, doing that same thing. Okay, so equation 3 is 3x minus 2y minus 4z equals 18. So I'm substituting in for x again here. So I have 3, 6y plus 2z minus 8 minus 2y minus 4z equals 18. I'm going to distribute 18y plus 6z minus 24 minus 2y minus 4z equals 18. Combine like terms. 18y and negative 2y is 16y. 6z and negative 4z is a positive 2z. And then I'm going to move my constant over. So 18 plus 24 equals 42. label that one. I'm running out of colors. Label that one equation number 5. Okay, so every single time you have a 3x3 system, okay, when you use substitution, you're going to end up with 5 equations, okay? Now, okay, I'm going to have to get on my, probably going to have to run out of room, but we'll see. Okay, now I'm using equations 4 and 5, okay, to solve a 2x2 system. Okay, so if you look at equations 4 and 5, okay, they both have y and z, so you can solve a 2x2 system. So let's do that. Okay, so I have negative y plus z equals negative 6. And I have 16y plus 2z equals 42. Okay, if I isolate this first equation for z, what do you get? Z equals negative 6 plus y. Okay, so now we can substitute this in for z. So I have 16y plus 2, negative 6 plus y equals 42. 16y minus 12 plus 2y equals 42. 18y minus 12 equals 42. 18y equals 54. So what does y equal? Y equals 3. Okay, so staying within your 2x2 system, okay, z equals negative 6 plus 3. So what does z equal? Negative 3. Okay, so we have y and we have z. Okay, so now we take our y and z all the way back to the beginning so that we can solve for x. So you take y and z all the way back to the beginning. Okay, so I have x. I'll use my green. I have x minus 6 times 3 minus 2 times negative 3 equals negative 8. X minus 18 plus 6 equals negative 8. X minus 12 equals negative 8. Add 12 to both sides, and x equals what? 4. Okay, and the answer to your solution is never written just like x equals 4, y equals 3, z equals negative 3. Start getting in the habit of writing your answer as an ordered pair. Okay, and you write it in alphabetical order, x, y, z. Okay, so our answer is 4, 3, negative 3. 4, 3, negative 3. So, now we are done. Okay, so it's not necessarily that it's hard, it's just tedious. Okay, and you've got to make sure you keep track of your work and keep it in an organized way. Okay, every problem like this is going to require this much work. That's why you're not going to have a test of 10 of these, because they take time. Okay, so just make sure that you have a way of organizing your work. You can always, after you get your x, y, and z, plug x, y, and z into your 3 equations and make sure that they all check out to be true. Okay, if they don't check out to be true, then you know you've made a mistake. But that's the beauty of systems. You can always substitute back in and see if you get true statements. Okay, I know that's a lot of steps, but are there any questions? Did I lose anybody in the process of doing example 1? We're okay? Okay, those of you that are doing example 2, great. We're going to skip it. Okay, your solution is there if you choose to do it. The easiest way for this one is if you isolate y. Okay, if you choose to isolate y, you will be better off than if you choose z. Okay. All right, example 3. Okay, so just like when we solved the linear and the quadratic and how there was special cases of one solution, two solutions, infinite number of solutions, no solutions, okay, all those special cases. Okay, we also have special cases when we solve 3 by 3 systems, okay? So you can have a given one solution, you can have infinite solutions, or you can have no solutions. Okay, so we're going to look at the next two examples and we're going to see some of these special cases. Okay, but before we do that, have you heard of scaling equations? Does anybody know what it means to scale an equation? Okay, I figured. Okay, all scaling an equation does is make your life a little bit easier. Okay, for example, do you guys want to do that system of what we just did with fractions? No. Probably not. Okay, so we can scale them. If we multiply this entire equation by 3, we can get rid of those fractions. Okay, so this will give us 3p plus 2q plus 3r, plus 1r equals 3. Okay, in the first equation, you have 2p minus 6q plus 2r equals 8. Is there anything that we could use to get that simpler? Divide by what? 2. If you divide everything by 2 or multiply everything by 1/2, okay, you're going to be left with p minus 3q plus r equals 4. Okay, and then what could you do to the third equation? Divide by 2 again. Okay, or multiply by 1/2. So you have negative 6p minus 4q minus 2r equals 1. Okay, to make life even easier for that bottom equation, rather than multiplying just by 1/2, what could we have multiplied?
4.
Negative 1/2, and then all of those things become positive. So that way you don't even have to deal with negatives. Okay. So if we start this same process, okay, that we did last time, what do you think we should isolate? P, and I'm guessing y'all are talking about our first equation. Okay, so let's number them 1, 2, 3. Okay, so if I'm working with number 1, I have to isolate P. So P equals 3q minus r plus 4. Okay, now, yes.
For the third equation, if you divide by -2, it would be -1 on the...
Yes. Thanks. He's right. On number 3, since I multiplied by that negative 1/2, it should be equal to a negative 1. I flipped the other signs, but forgot to flip that one. Okay, so now we are substituting into equations 2 and 3 for P. So just like last time. Okay, so if you want to jump ahead and move forward at your own pace, you're more than welcome to. Okay, I'm substituting P in right here for these two equations. Okay, for that first one, did you guys get 11q minus 2r equals negative 9?
Yes.
Okay, now do the same thing with equation number 3. On the next one, did y'all get 22q minus 4r equals negative 23? Or did I mess up? Those of you who are there?
It's negative 25.
Negative 25. Oh, yeah, because minus 24 from both sides. Thanks. Are we good now? Okay, so let's label those 4 and 5. Okay, so I'm going to have a 2 by 2 system with 11q minus 2r equals negative 9 and 22q minus 4r equals negative 25. Okay, I'm going to use elimination on this one to get rid of my q's. What am I going to multiply this top equation by? Negative 2. Okay, so I have negative 22q plus 4r equals 18. And then I have 22q minus 4r equals negative 25. Okay, what happens when I add these? So I get 0 equals what? Negative 7? Is that a true statement? Okay, because this is false, when you solve your 2 by 2 system, your answer is no solution. Okay, so if you are solving and you get a false statement, okay, 0 does not equal negative 7. Hopefully we all know this. Okay, then it is no solution. Okay, so this is one. So we've done 2 cases now. A case that has a solution and a case with no solution. Okay. Questions on example 3. Okay, so there's really no easy way to detect no solution until you start working them. Okay. However, for our next example, example 4, okay, it's going to be a little bit easier. Okay, what do you notice? Let's number our equations first. 1, 2, 3. Do you notice anything particular about these 3 equations? Are they opposite or the same? The same. What did I multiply number 3 by? Negative 1, or I multiplied number 1 by negative 1. Okay, they're the same exact equation. Okay, so if you notice that you have the same equation, okay, if you were to solve those for y, you would get the same thing. Okay, then your answer is always going to be infinite solutions. So if you have 2 equations that are the same, your equations are always going to be infinite solutions. Okay, the reason being, okay, when you have a 3 by 3 system, you're talking 3-dimensional, okay, and you're on planes. Okay, so if you have 2 lines that are the exact same, okay, obviously those are intersecting at infinitely many points because the lines are the same. Okay, so So between those two lines, they would share the same x and y value infinitely many times, okay? However, once you add that third line, okay, z, let's say, okay, could be anything. So that is why you always have an infinite number of solutions if you have two lines that are the same. Okay, we're going to get into that further later on in this unit. But that is something to look for, okay? So you're going to have one solution, no solution, or infinite solutions, okay? Had you worked this out, okay, you end up again just getting two lines that are going to have the same equation, and then you'll be left with, when you solve that 2 by 2 system, 0 equals 0. Okay, so after you solve the 2 by 2 system, you're left with 0 equals 0, which is true, and that means you have infinite number of solutions. Okay, so say you weren't able to identify right away that those two equations are the same. If you do work through that system, you get 0 equals 0, which means infinite solutions. Questions on any of that? Okay, we're going to do one more together, and then I'm going to set you free. Okay, I just want to talk about using elimination instead of substitution every time. Okay, elimination can save you a step. However, if you're more comfortable with substitution, then you can substitute away every single time. Okay, but for example, in our first two equations, again, if I number them, what could I multiply equation number 1 by so that I could get rid of my x's? -2. Okay, so that's going to yield -2x plus 4y minus 2z equals 0. Then you have 2x plus y minus 3z equals 5. When I add those together, my x's cancel. I have 5y minus 5z equals 5. Did I do that right?
Yeah.
Okay. And then this way, now you already have, okay, one variable that's been eliminated. Okay, what can I simplify that equation to? Y minus z equals 1. So do you notice how if we multiply the whole thing by 1/5, you have y minus z equals 1? Okay, now what can I scale equation 2 by so that I can eliminate the x's in equation 3? -2. So now let's multiply this guy by -2. So I have -4x minus 2y plus 6z equals -10. 4x minus 7y plus z equals -1. When I add the two together, -9y plus 7z equals -11. Are we good? Okay, and then you're left with solving a 2 by 2 system. Okay, so I've kind of done the hard part for you. Solve that 2 by system on your own, okay, and then go solve for x. So solve for y and z, and then go back and solve for x. Remember to write your answer as an ordered pair. Okay, you should get 3, 2, 1. Any questions on example 5 using elimination? Okay, so I just wanted to show you guys 2 different approaches to be able to solve these problems. So if you want to use elimination, great. If it works out, okay, obviously there are times when substitution is the easier method. Okay, are there any questions? Okay, in your packet you have 2 problems. Okay, they're little practice problems, I believe. Okay, on the left-hand side, okay, I used elimination. On the right-hand side, I use substitution. Okay, so if you want to have a crack at those, okay, the answers will be up here. Otherwise, I'm going to pass out your homework, and you have the rest of the time to work. Okay, your homework's going to have problems like these. The practice is going to have problems like these. So either way, you're going to be solving 3x3 systems algebraically. Okay, you can just choose the problems that you want to look at, I guess. Questions? Okie dokie.